about the ideal gas. I'm going to try to explain you what does the ideal gas law state and who made the ideal gas and why it is important and how it works. First, what does the ideal gas law state? This law states that the product of the pressure and the volume of 1 gram of molecule of an ideal gas is equal to the product of an absolute temperature of the gas and the universal gas constant. An ideal gas is a hypothetically gas trained by chemists and students because it would be much easier if things like intermolecular forces do not exist to complicate the simple ideal gas law. Ideal gases are essentially point masses moving in constant, random, and straight line motion. This behavior is described by the assumptions listed in the kinetic molecule theory, and this definition of the ideal gas contrasts with the non-ideal gas definition because this equation represents how gas actually behaves in reality. For now, let's focus on the ideal gas. We must emphasize that this gas law is ideal. As students, professors, and chemists, we sometimes need to understand the concepts before we can apply it. And assuming that the gases are in ideal gas state, where it is unaffected by real-world conditions, will help us better understand the behavior of the gases. In order for a gas to be ideal, its behavior must follow the kinetic molecule theory, whereas the non-ideal gas will deviate from this theory due to real-world conditions. Before we look at the ideal gas equation, let's state the 4 gas variables and 1 constant for a better understanding. The 4 gas variables are pressure, volume, the number of moles of a gas, and the temperature. Lastly, the constant of an equation is always known as the gas constant, which is 0.082. One thing to keep in mind is that know what the standard temperature and pressure values are, know how to do the stoichiometry, and know your basic equations. We're going to try to solve some problems or examples of the ideal gas law, and let's remark that the units must cancel out to get the appropriate unit. Knowing this will help double check your answer. So we're going to start. Before starting with the problem, we are going to get to know our formula. This is the ideal gas law formula. We're going to know what the letters stand for. P stands for the pressure, B for the volume, always in liters, N for the number of moles, R is the ideal gas constant, it is always 0.082, and the T stands for the temperature, always in kelvins. The problem says, if I have 17 moles of a gas at a temperature of 360 K and a volume of 88.89 liters, what is the pressure of the gas? First, we need to know what we know and what we need to know. At the moment, we don't know what the pressure is. We know that the volume is 88.89 liters. The moles are 17. We already know that the constant pressure is always 0.082 and the temperature it is 360 K. we need to find the pressure. To find the pressure, we are going to use the ideal Gauss law, and here's a formula. I'm gonna write it down. So the formula is pressure times volume equals to the number of moles times the constant times the temperature. Since we don't know the pressure, we're gonna write an x as a variable, times the liters times the number of moles, which is 17. We write the constant and the pressure and the temperature. To solve this equation, we are just gonna divide the volume, because we need the x by itself. So we are going to divide it by the total amount, which means by all of the variables. Now that I'm doing it in a calculator, the answer is 5.64. We have the value of x, which is the value of the pressure. This is all that we had to do. The other variables are always given. We will always use the same process to find the other variables in any case.